Okay, in this video we're going to be going over the study sheet for exam number 3, which is on Monday in class. You will have a help sheet, and the problems on this exam are similar to the ones that will be on the actual exam number 3. In number 1, you're going to write the number 0.752 as a sum using powers of 10 to show place value. So in this case here, 0.752, the 7 is the first number after the decimal point. That's the 10th place. So we're going to write that as 7 multiplied by, and the 10th place in exponential form is 10 to the negative first power. And then the 5 is in the hundredths place. So here, hundredths is like 10 to the second, but since it's two numbers behind, the second number behind the decimal point, it's going to be 10 to the negative 2. And then plus 2, that number is in the thousands place. And I need to change that to 5 times 10 to the second. And then this will be 2 times, and it's in the thousands place, so it'll be 10 to the negative third power. Okay, so that's how we write that in expanded form using powers of 10. Alright, number 2. Write as a decimal in numbers. In this case, 270 and 2/10. So 270, that's the whole number. That's 270. The word "and" is the decimal point, and then 2/10. Now, the 10th place is only one number behind the decimal point, so the 2 has to be fit. We have to fit this number in that slot. In this case, it'll be 2, so it'll be 270.2. Okay. Now, on the help sheet, you will have the place value chart on there to help you on this. So you have to know, be familiar with your place value positions here. Number 3, write the number 0.039 in words. Well, we read this as a whole number, as if it was a whole number. In this case, the 3 and the 9, we read that as 39. And I'm going to give the word 39 the name of the place value that the very last digit is in. The last digit is a 9. That number is in the thousands place. Here you got the decimal point here, and then you got tenths, hundredths, thousands. So we're going to give it the name where the last digit, the place value that number is in. So it's 39 thousandths. Alright, number 4. Without performing the actual division, determine whether the fraction 13/40 represents a terminating decimal. Alright, in this case here, there is a rule where we determine whether or not we have a terminating decimal, and that's this. A rational number a over b in simplest form can be written as a terminating decimal if and only if the prime factorization of the denominator contains no primes other than 2 or 5. So it must only contain a prime factorization with only 2 and 5 in it for it to be a terminating decimal. So in this case, the denominator is 40. So here I'm going to get the prime factorization of 40 using a factor tree. Let's see, 40 would be something like 4 times 10. We'll start with that. And then 4 can be broken up as 2 times 2. 2 is a prime number. And then 10 can be broken up as 2 times 5. 5 is a prime number. So in this case here, I only have 2 and 5 as prime numbers here. I have no other primes other than 2 and 5. So here, 13 over 40 is considered to be a terminating decimal. Okay. All right, any questions on number 4? All right, number 5 is to write the fraction 7 over 8 as a decimal. Now I'm going to have to pull this paper up so that y'all can see this. Alright, 7 over 8. Here we divide the denominator into the numerator using long division. And in this case, I had to place a decimal point behind the 7 and bring it up in the quotient, add a 0. And then I can divide 8 into 70. That's going to go 8 times. Then 8 times 8 will be 64. 64 from 70 will give us 6. Here I'm going to add another 0 and bring that down. 8 goes into 60 7 times. So here's 7 times 8 will be 56. Subtract 56 from 60, you're going to get 4. Now I need to add another 0 and bring that down where the 4 is, and then divide 8 into 40. That's going to go 5 times. And then 8 times 5 will be 40. And if I subtract 40 from itself, I'm going to get a 0 remainder. So in this case, 0.875 will be the decimal equivalent for the fraction 7/8. Alright, number 6 is to arrange in order from smallest to largest. We got 0.6303, 0.63, and 0.5651. And we're going to put these in numerical order from smallest to largest. So what I would do is place these numbers lined up, place value by place value. And then 0.63, I will add 2 zeros. That way I have the same number of place values, positions, as I have with the other numbers. And then I compare each place value. The zeros are the same here. Now the tens place, notice from smallest to smallest number will be the 5. And that will be this number right here, 0.5651. That will be the smallest. Okay. So now I only got 0.6303 and 0.6300. So here, well, by looking at this, the next smallest will be 0.6300, or simply 0.63. And then the largest will have to be 0.6303. So these are the numbers, or decimals, arranged in order from smallest to largest. Okay. Number 7. Brianna went to the store and bought a chair for $16.03, a rake for $14.46, a spade for $9.85, a mower for $144.55, and 2 6-packs of water for $2.35 each. What was the bill? So pretty much we're just getting a total here. Let's see. A chair was bought for $16.03. A rake, $14.46. A spade for $9.85. A mower for $144.35. And 2 6-packs of water, $2.35 each. And notice I'm writing the $2.35 twice, because in this case here, she bought 2 6-packs of water. Okay, now, when you show your work, at least show this part right here. And then, pretty much add. In this case here, your total will be $189.39. Okay. So that would be the total bill for this particular case. Number 8. The water in the tank weighs 693.75 pounds. 1 cubic foot of water weighs 62.5 pounds. How many cubic feet of water does the tank hold? Well, in this case here, we're going to have to do a little bit of division here. Like divide 62.5 into 693.75. Now notice I want to make this divisor a whole number, so to do that I need to move the decimal point one place to the right, like this. Now if I move the decimal point one place to the right in the divisor, I have to do the same thing. Move the decimal point one place to the right. So the decimal point will be behind the 7, and I'll bring this decimal point straight up in the quotient. And now we'll go ahead and divide. I'll do 625 into 693. That's going to go one time. So 1 times 625 will be 625. Now subtract 625 from 693, you're going to get 68. And then bring down the 7. And then divide 625 into 687. That's going to go one time. Multiply 1 times 625, you'll get 625. And then subtract 625 from 687, you're going to get 62. Then bring this 5 down where the 62 is, and we'll divide 625 into 625. That's going to go one time. So 1 times 625 will be 625. And subtract, you'll get a 0 remainder. So here, to answer that question, it would take 11.1 cubic feet of water for that particular tank. Okay, so the tank holds 11.1 cubic feet of water. Right, number 9. A bank statement shows a checking account with a balance of $82.49. The balance recorded in the checkbook shows only $26.94. After checking the canceled checks against the record of these checks, the customer finds that the bank has not yet recorded 6 checks in the amounts of $2.97, $12.29, $5.59, $13.16, $14.57, and $6.97. Is the bank record correct? And explain. Okay. Well, the bank shows $82.49, and the checkbook shows $26.94. Okay. So now we got 6 checks of $2.97, $5.59, $12.29, $13.16, $14.57, and $6.97. Okay, now I'm going to make that a plus sign. So here we're going to add these numbers together. We should get you should get $55.55. Those are the sum of the 6 checks here. Okay, so now if we add those check totals to the $26.94, we get $82.49. So here, the bank record is correct. Okay. All right, now number 10. In number 10, you're to convert 8.8 times 10 to the negative 7 to decimal notation. Okay, so this is what we call scientific notation. We want to convert that into decimal notation. In this case here, our exponent for the power of 10 is negative 7. So in this case, we need to move the decimal point in the 8 7 places to the left. And in the 8, the decimal point is understood to be behind the last digit. So we move this decimal point 1, 2, 3, 4, 5, 6, 7. And in this case, we need to add zeros in this particular situation. So that means 6 zeros need to be added in front of the 8. So that means 8 times 10 to the negative 7 would be 0.6 zeros followed by the 8. Okay, now if that exponent was a positive, then we move the decimal point to the right. Okay. In number 11, it says the distance between two planets is 21 billion meters. Write this numeral in scientific notation. So here we got 21 billion. That's 21 with 9 zeros behind it. And we want to convert that into scientific notation. What we do here, we want scientific notation, the first part to be a number that is at least 1 but less than 10, multiplied by a power of 10. In this case here, we need to place a decimal point behind the very first digit in this number. So that decimal point will be behind the 2. So it's going to be like 2.1, and it's going to be multiplied by 10. Now, if I place the decimal point behind the 2, I need to count how many numbers are there behind the decimal point. That will tell me the exponent for 10. In this case, there are 10 numbers behind that decimal point. So it'll be 2.1 times 10 to the 10th. Okay, number 12. Here we're going to multiply two numbers that are in scientific notation. Like 2 times 10 to the 6th times 7 times 10 to the 12th. In this case here, I'm going to multiply the numbers in front, like 2 times 7, that's going to give me 14, times, now when we multiply powers of the same base, we only add the exponent. So here, 10 to the 6 times 10 to the 12th, we bring over the base of 10 and add the exponents of 10. So 6 plus 12 is 18. So I got 14 times 10 to the 18th power. Unfortunately, that is not in scientific notation because the 14 is bigger than 10. Scientific notation states that the first part has to be a number at least 1 but less than 10. So, what I need to do here is put a decimal point behind the 1. And when I do that, I'm going to have a 1.4. That's going to be multiplied by 10. Since I placed the decimal point behind the 1, there's only one number behind it. So that's 10 to the 1st. And then that's going to be multiplied by 10 to the 18th power. So the number 14 was converted into scientific notation, 1.4 times 10 to the 1. And then finally, I'll add my exponents for the power of 10. Here these bases are the same. Bring over the base, add your exponents. 1 plus 18 will be 19. So the final answer there will be 1.4 times 10 to the 19th power. Okay. All right, number 13 is rounding. We got 549.926. We're going to round to the nearest hundredth, to the nearest tenth, to the nearest unit, to the nearest 10, and to the nearest hundred. Okay. In this case here, we got 549.926. So here we're going to round first to the nearest hundredth. Hundredth. Alright, in this case here, the hundredths place is the second digit after the decimal point. In this case is a 2. To the right of it is a 6. Okay? We round up if it's 5 or greater. We keep it as it is if it's less than 5. In this case, that digit is bigger than 5. So we round the 2 up to a 3. So it'll be 549.93. And we drop off the numbers that are immediately after the place value that we're rounding off to. So to the nearest hundred, it'll be 549.93. And then next to the nearest tenth. Now the number in the tenth place, that's the first number after the decimal point, is a 9. To the right of it is 2. 2 is less than 5, so we leave the 9 as is. So it'll be 549.9, and the 2 and the 6, we drop that off completely because we're rounding to the nearest tenth. So it'll be 549.9. Next is the nearest unit, which is another way of saying the nearest whole number. That's going to be the number in front of the decimal point. That's this 9 right here. To the right of it is another 9. That's bigger than 5, so we increase the 9 to a 10. But after 549 comes 550. So to the nearest unit, it will be 550. Next is to the nearest 10. The digit in the tens place is this 4 right here. To the right of it is a 9. That 9 is bigger than 5, so we increase the 4 to a 5. So it'll be 5, 5. And since we're rounding to the nearest 10, this 9, which is in the ones place, changes to a 0. And all the numbers after the decimal point, we drop off completely. So it'll be 550 for this number to the nearest 10. And finally to the nearest hundred. The digit in the hundreds place is a 5. To the right of it is a 4. That 4 is less than 5, so we leave the 5 as is. And we change the 4 and the 9, which are the numbers that are in front of the decimal point, to zeros. All the numbers after the decimal point fall off. So it'll be 500. Alright, number 14. The heaviest apple on record weighed 5.0557 pounds. The heaviest lemon weighed 12.682 pounds. How much heavier was the lemon than the apple? Well, by how much we want to subtract. So, the lemon is 12.682 pounds. We're going to subtract from it the weight of the apple, which is 5.0557. And to have the same number of decimal places for both of these numbers, I'll put a 0 behind the 12.682. And then subtract. Now we're going to have to do some regrouping because we can't subtract 7 from 0. 1 from this 2 will give us a 1. And that 0 will become a 10. So if I do 10 minus 7, that's going to give us 3. And now I can't subtract 5 from 1, so a little regrouping has to be done here. Take 1 from the 8, you'll get 7. Add 1, add 10 to this 1, you're going to get 11. Now 11 minus 5 would give us 6. And then I can do 7 minus 5, that's going to give us 2. 6 minus 0 is 6. And if I do 12 minus 5, I'm going to get 7. So here, the lemon was 7.6263 pounds heavier than the apple. Okay. Right, number 15. Find the decimal representation for, and in part A you got 9/11ths, in part B 5/12ths. Let's start with 9/11ths. So here we got to do long division by doing 11 into 9. Now I need a decimal point after the 9 and place it in the quotient and add a 0. And now I'm going to divide 11 into 9. That's going to go 8 times. 8 times 11 will be 88. Subtract 88 from 90, you're going to get 2. Add another 0 and bring this down. 11 goes into 20 one time. 1 times 11 will be 11. 11 from 20, you'll get 9. Then I'm going to add another 0 and bring that down as well. 11 will go into 90 8 times. 8 times 11 will be 88. 88 from 90 will give us 2. If I add another 0 and bring that down, 11 goes into 20 one time. 1 times 11 will be 11. 11 from 20, you'll get 9. And notice that the 8 and the 1 repeats. So, 9/11ths would be, as a repeating decimal, 0.81. And I'll put a bar over the 8 and the 1, indicating that the 8 and the 1 repeats. Okay. So that was part A. In part B, we got 5/12. And I want to convert that into a decimal. Well, I need to divide 12 into 5. I need a decimal point after the 5 and a 0 behind it. The decimal point goes in the quotient. Now if I divide 12 into 5, that's going to go 4 times. 4 times 12, that's 48. Subtract 48 from 50, you're going to get 2. Add a 0 and bring that down. 12 into 20, that's going to go 1 time. 1 times 12 will be 12. Subtract 12 from 20, you're going to get 8. Add another 0 and bring that down. 12 goes into 80. Let's see, 6 times 12 will be 72. 72 from 80 will leave me 8. Now if I add another 0 and bring that down, we can see 12 goes into 80 again. 6 times. 6 times 12 will be 72. 72 from 80 would leave me with 8. And pretty much you can see that only the 6 is going to be repeating each time. So here 5/12 as a decimal will be 0.416, and I'm only putting a bar above the 6 to indicate that only the 6 repeats. Alright, number 16. Convert the repeating decimal to a fraction in simplest form. And in part 4.27, where the 2 and the 7 repeats, and 0.48, only the 4 and the 8 repeats. Okay, so now we're going to use the fact that 0.1 is actually 1/9. 0.01, only the 0 and the 1 repeats. That's 1 over 99. And 0.001 with a bar over those 3 digits. That's 1 over 999. We're going to use that fact to help us come up with a fraction for that number. Like in part A, you got 4.27. The 2 and the 7 repeats. Well, I'm going to bring over the whole number. That's going to be the 4. The number under the bar will be your numerator, which is going to be 27, over 2 numbers repeat, so my denominator has to have the 9 and the 9. So it'll be 4 and 27 over 99, which can be reduced by dividing the numerator and the denominator by 9. So it'll be 4 and 3/11. And we can just leave it as a mixed number, 4 and 3/11. Now part B is 0.48. The 4 and the 8 repeats. So in this case here, my denominator, since 2 digits repeats, is going to be 99. The 4 and the 8, that's under the vertical bar. That's your numerator, so you have 48 over 99. And this can be reduced by dividing the numerator and the denominator by 3. So in this case here, this will be 16 over 33. Alright. Number 17. Find a rational number between 3/5 and 0.60, where the 6 and the 0 repeats. Now if I do 3/5 as a decimal, that's going to end up being 0.6. And of course you can do 5 and the 3, you'll see that it end up being 0.6. Now 0.60, where the 6 and the 0 repeats, that's this, 0.60, 60, 60, like that. Now I'm adding 5 zeros after the 6. Now, the answers here will vary, but as long as you pick a number that is between these two numbers, that's fine. One number would be 0.601. And that falls between 0.6 and 0.60 repeating. Alright, number 18. I think that's ordering numbers from greatest to least. 0.7, 0.7 repeating, 0.73 repeating, 0.733 repeating. Now line these up, 0.7, then 0.7 with a bar, 0.73, the bar is on both, 0.733, the bar is on all three. Now I'm going to expand 0.733 to 0.733, 733, and so on. 0.73, 0.73, 73, 73, and that goes on. 0.7, only the 7 repeats, so I'm just going to write the 7 like this. And then 0.7, I'm going to put zeros behind it. Now, from the greatest to the least, well, in the 10th place, the 7s are the same. But in the 100th place, the largest digit that I see in the 100th place is this one. So that means 0.7 repeating must be the largest. Okay, I'm going to put a check by this one so that way I won't select that one again. Now I have the other two. Let's see, this one This one is the largest. So the next largest will be 0.73 repeating. So if this is the largest, then that means after that will be 0.733 repeating. And the smallest will have to be 0.7. Okay. So that's the order from greatest to least. All right, number 19. In number 19, it's just a true-false question. The square root of 4 is an irrational number. If I take the square root of 4, that means what number times itself will give me 4? It has to be 2. Now, irrational numbers are numbers that are non-terminating, non-repeating. This right here is a terminating decimal here. Okay? So here, if it's not a non-terminating, nor if it's a non-repeating decimal, that means that this can't be an irrational number. So that answer there basically would just be false. It came out to be a rational number. Only irrational numbers have non-terminating, non-repeating decimals. That's it. Number 20. Without using a calculator, find the principal square root of 169. So I want to find out what number multiplied by itself that would give me 169. In this case, it's going to be 13. Because 13 times itself would be 169. Alright, number 21. Which of the following are irrational numbers here? So here you have to select which one of these numbers will be irrational. Those are, of course, non-terminating, non-repeating decimals. So if we go through each one of these, negative 12 is a rational number. It's rational because it's a negative whole number. 0, that's rational because, of course, that's considered to be part of the set of integers. 8 is rational because that's a positive number and it's a whole number. 2.38 is a terminating decimal. That is considered to be rational. Now for the square root of 2, that's irrational. Here's why. If I take the square root of 2, I'm going to get a non-terminating, non-repeating decimal. Okay? So here, option E is irrational. Now for the square root of 49, if I take the square root of 49, that's going to give me 7, which is rational. 7 and 1/6 is rational because that is a fraction. Fractions are rational numbers. Negative 17 over 31, that's rational as well because that is a fraction there. I is irrational because I have a pattern of non-terminating, non-repeating. So I, which is 1.39993999, and then 3 goes on and on and on. That's irrational. These are your irrational numbers here. Options E and I. Number 22 is this. A car company is offering car loans at a simple interest rate of 4.7%. Find the interest charged to the customer who finances a car loan of $7,200 for 3 years. Now here we're looking for the simple interest, which is only this formula, I is equal to P times R times T. And in this case, that principal is $7,200. That's going to be multiplied by this simple interest rate of 4.7%. Now, as a decimal, it's going to be this, 0.047. Here you can take 4.7, divide that by 100, you'll get this decimal, 0.047. And then that's multiplied by 3 years. So simply we just multiply 7,200 by 0.047 by 3. And then hit enter. Now since we're dealing with dollar amounts, I'll add a 0 behind that too. So it'll be $1,015.20. Okay, so that's number 22. Now number 23 is a chart that you're going to have to complete. It deals with compound interest. Okay. For each one of these, the principal is $2,500. Each one you have a varying annual interest rate, the length of time given here, the number of periods given here. We need to find out what the interest rate per period is going to be, the amount of the interest paid, and the total amount in the account. Alright, now, let's start off with semi-annually. For semi-annually, it's 2 compoundings. Okay. So now, you're told that the annual interest rate is 8%, so what would be, and the length of time in years is 3 years. Okay. Now, to find the interest rate per period, we take that annual interest rate of 8%, divide that by the number of years. I'm sorry. We divide that by the number of compoundings in a year. Okay? The number of compoundings in a year. We divide that into the interest rate. Since there are 2 compoundings in a year, we're going to do 8 divided by 2, which is actually going to be 4%. So the interest rate per period, that's going to be 4%. That's going to be the interest rate, 4%. Now the formula that we're going to be using for the amount that's in our account will be 1 plus r raised to the n. Now in this case, the r is going to be the interest rate per period. The n is the number of periods that are given to you. Okay? And that should be p times. I'm sorry. A is equal to P times the quantity 1 plus R raised to the N. So here to find out what A is, the P, which is your principal, that's the $2,500. That's multiplied by 1 plus, the R is going to be that interest rate per period. In this case, that's just 4%. Now 4% as a decimal will be 0.04. Raised to the n, which is the number of periods here. Here's your number of periods right there. That's 6. That would be your exponent here. And in this case here, we use our calculator to figure this out. Here we're going to do 2,500, and then left parentheses 1 plus 0.04 close parentheses, and then we're going to press the hat key for your exponent, and then 6, and then hit enter. Now we're going to round that off to 2 decimal places, so that amount will be $3,163.30. And now, on your chart, that's going to be the total amount in the account of $3,160.30. $3,163.30. So this is 3,163.30. Now to find the interest that's paid, the interest will be that total amount minus the principal. Okay. So here the interest paid is the total minus the principal. So that total that we got there was $3,163.30 minus the principal, which was $2,500. So if we subtract that, you're going to get $663.30. So the interest paid is $663.30. So here we go, 663.30. That goes here. Okay. Now for quarterly, there are 4 compoundings in a year. So let's do that one. So the interest per period, or the interest rate per period, let's see, that interest rate was given to you as 10% in that problem, so it'll be 10 divided by 4. 10% divided by 4. That will be 2.5%. So the interest rate for each period will be 2.5%. So that goes here. 2.5%. That goes here. Right, and now let's find out what the amount is going to be using A is equal to P times 1 plus R raised to the n. And then we're going to simplify that. So A is equal to P, which is still 2,500, multiplied by 1 plus R. Now 2.5% as a decimal, you can do 2.5 divided by 100, and that will give you the decimal value of the interest rate, 0.025, raised to the n. And in that problem, you're told the number of periods. N is the number of periods in this case. That's 20. So this will be to the 20th power. So in this case here, we type that in, 2,500, and then left parentheses 1 plus 0.025, close parentheses, press the hat key for your exponent, and then 20. Now this will give you $4,096.54 to 2 decimal places. So the amount total is $4,096.54. So that goes in the total amount in the account spot. $4,096.51. Now to find the interest paid, we subtract $4,096.51 minus the principal of $2,500. So the interest paid We know that's the total minus the principal, so 4,096.54 minus the 2,500. That will give you $1,596.54. So the interest paid was $1,596.54. And that amount will go here. Okay. So that's going to be the interest paid. Subtract the total minus that principal, you get the interest paid. And for monthly, that means that there are 12 compoundings in a year. So if it's compounded monthly, that means n is equal to 12. So that means that the interest rate per period is this. That interest rate this time, they tell you is 12%. So if I do 12% divided by 12, that's just going to be 1%. So for each period, the interest rate is 1%. So I'm still going to use that formula. A is equal to P times 1 plus R raised to the N. Your P is still $2,500 times 1 plus the interest rate per period is 1. But 1% as a decimal will be that 0.01. Raised to the N, that's the number of periods. Here, that's 84. That's given to you. And before I move on, calculate that interest rate per period, that goes here, 1%. So I'll just go ahead and fill that in. And now we'll go ahead and calculate that, 2,500. Left parentheses, 1 plus 0.01, close parentheses, press the hat key for your exponent, and then 84. So here we got $5,766.81. So that's the amount in the account that goes in this last column right here, 5,766.81. Now for the interest paid, we subtract 57.66 and 81, subtract that minus the 2,500. So here, your interest paid, that's going to be 5766 and 81 minus 2,500, and that will give you, let's see, 3,266.81. $3,266.81. That's going to be the interest paid. And that amount goes here. Okay. So that's how you'll complete that particular compound interest chart. Alright. Number 24. A diagonal brace is placed in a 15-foot by 10-foot rectangular gate. What is the length of the brace to the nearest tenth of a foot? And sometimes with this one, it helps to draw a picture of what that looks like. So we have a rectangular gate that looks like this, and a diagonal brace is going to go here. And the rectangular gate is 15 feet by 10 feet. And I want to know the length of this diagonal brace here, which I'm going to call X. Well, notice that this is in the form of a right triangle, so we have to use what they call the Pythagorean Theorem. Now, the Pythagorean Theorem, if you recall, is this a squared plus b squared equal to c squared. The a and the b are the lengths of the sides. The c is the longest side, which is the hypotenuse. Okay? So the square of the hypotenuse is always going to be the sum of the squares of the lengths of the other two sides of that right triangle. Alright, so here I'm going to let a be the 15. So that's 15 squared plus b, I'm going to let b be 10. So that's 10 squared. And this is the longest side that I'm trying to find here. So let's see, I'll let that be x. So that'll be 15 squared plus 10 squared is equal to x squared. 15 squared is 15 times 15. That's 225. Plus 10 squared is 10 times 10. That's 100. Equal to x squared. Add 100 to the 225, you'll get 325. That's equal to x squared. And to find out what x is, since we have x squared, we're squaring something, the opposite of squaring something will be to take the square root. So we need the square root of 325. So I'm going to do second and x squared. Second x squared for the square root. And then type in 325. And then hit enter. Now it says to the nearest tenth of a foot. So 18.0277563 to the nearest tenth will be 18.0. And this is in feet, so that means the length of this diagonal brace would be 18.0 feet. And finally, on your review sheet number 25, write the following phrase as a variable expression. 20 decreased by 2 times a number. Okay, well, the number 20, I can write that as 20. Now, the word decreased by, if something's decreasing, that means I'm subtracting 2 times a number. It'll be 2x. And I'm going to let x be the number. So that will be the variable expression for that phrase, 20 decreased by 2 times a number. Alright. And that should be enough to help you with exam number 3, which will be on Monday in class. And if you have any questions, do feel free to email me or stop by my office if you need the help.